Here, on the top of our board is a rate of change problems. I want you to just remember what a rate of change is. Rate of change problems is one of the applications of differentiation rather than normal and tangent line to a curve. Let's look at one example, and this example will be solved here. Here is an example. An inverted circular cone has a depth of 10 centimeter and the base radius of 5 centimeter. Water is poured into it at the rate of 1.5 centimeter cube per second. The question is, find the rate at which the level of water in the cone is rising when the depth is 4 centimeter. This is how we are going to solve this problem. To answer the question like this, let us draw an inverted circular cone and this way. An inverted circular cone. This is a cone of radius r and height h. This h is equal to this one. Assume that this is a circular cone, and the way the level of rising water increases depends on the way the radius is also changing. An inverted circular cone, let's draw another cone here. This is a cone of radius capital R and height capital H. To answer the question of this kind, what do? We take the ratio of R and its corresponding height and this uppercase letter R and its corresponding height. So, in our question, we've been told that our height was 10 centimeter, while our radius was 5 centimeter. We need to express this area in terms of this h. In which way we are going to do this? Let's follow. Here, uppercase letter R is equal to, let's multiply R, this lowercase letter R and this uppercase letter H. This is R H over H. Our radius in the middle of this inverted circular cone will be, let's replace H by 10 and the lowercase letter R by 5. This is 5 H over 10. Simply, this area is half of a H. So, let's come back on the volume of a cone. The volume of a cone is equal to a 30 of pi times the radius, which is straight, and multiplied by h. In our case, we are using uppercase letter R and H. This is the same as writing a 30 of pi R square H. Okay. We are going to replace these letters in the volume of a circular cone. This volume will be the same as a 30 times 5 times a half of h power 2, and we multiply also this h. The volume will be 1/3 times 5 times h squared by 4 times h, which is also 1/12 pi times h power 3. Okay. According to the question you've been given, that the change in volume with respect to 2t was 1.5 centimeter cube per second. And here we have the volume. Our volume here is 1/12, because it was expressed in terms of h. It is 1/12 times 5 times the h power 3. What we are going to see here, we are going to differentiate with respect to t. We are going to differentiate this volume with respect to time. What do we get? The change in volume with respect to t, we will differentiate this with respect to t. According to the formula that when you have u power n and differentiate this is u, we bring down this u, we differentiate u, and then we multiply by u power n minus 1. Here, this is a theorem. This theorem is going to be applied here. Differentiating this with respect to t, we'll keep this or this as a constant, which is pi by 12, and then let's differentiate h power 3. Differentiate this. This changing v with respect to t will be pi by 12 times the derivative of h power 3 will be 3 times the h is here, negative 1 here, times h prime. This h prime is the derivative of h with respect to 2t. That is how our rate is changing as time changes. It's dh by dt. Remember, in our question, they asked us to find the letter to which the level of water in the cone is rising. This is what we are going to look for according to this equation. The change in v with respect to 2t is equal, simplify 12 by 3 is on pi over 4 times h squared dh with respect to 2t. From here, crossing multiplication, we have 4 times the change in v with respect to 2t, which is equal to h power 2 dh with respect to 2t. Here, the h with respect to 2t is equal to 4 times the change in v with respect to 2t. I'm sorry, here I've gotten this 5. This has to be multiplied here. The change in h with respect to 2t is then equal to 4 times the change in v with respect to 2t over pi h squared. We are going to replace h and the change in v with respect to 2t as we've been given this. Here in our question, our h was 4. Our h was 4 centimeters. Okay. The change in v with respect to 2t is then equal let's say at h, which is 4, it will then equal to 4 times our change in v with respect to 2t was 1.5 centimeter cube per second over pi times 4 over 2. Simplify this. I'm sorry, this is h. We are going to simplify 4 and 4 here. This we cancel this here to stay with the change in h with respect to 2t as 1.5 centimeter cube per second over 4 pi centimeter square, because the square of 4 here, the h was 4 centimeter. Here is 4 centimeter square. Simplify this and this. Above we stay with 1.5. The change in h with respect to 2t is that equal to 1.5 centimeter per second over 4 pi. This is the level at which the water is rising is this. You can use calculator to work out this. 1.5 centimeter per second over 4 pi. That's it. Thank you.